Understanding artificial lighting systems, especially when traveling internationally or shooting high frame rates or slow motion videos, we can get a flicker in our shots. You have seen it before, but most videographers ignore it. Today, I'll be talking about how and why it happens and how to eliminate it when it happens. Now, in order to eliminate the flicker, we have to set our camera to the right frame rate or shutter speed or angle. I've encountered this several times until recently when I decided to pay much attention to it or understand what was actually happening or the maths behind the solution or even why there are limits to how high or high speed video you can shoot in artificial light. But now I do, based on further studies, research and videos I watched from filmmaker Griffin Hammond and photo Joseph. Filmmaker Griffin Hammond made a video called 3 Maths Hack Every Filmmaker Should Know, where he talked about avoiding light flicker in video from artificial lighting, and he also said something that really clicked in my mind, that between shutter angle or shutter speed and frame rate, you only have to get one right to avoid the flicker. If you are shooting at 30 frames at North America or 25 frames at most of the rest of the world, then you can shoot at any shutter angle or speed you want and light flicker won't be a problem. It's when you bring an NTSC camera to the power region or vice versa, or when you start shooting high frame rates for slow motion video, that is when flickering becomes a problem. There's a limit to how many frames per second you can shoot before it becomes impossible to avoid flicker. To fully explain this, there are 2 fundamentals you need to be clear on. Firstly, why shutter speed or angle has limits when shooting video, and second, how the power system and electrical lighting works. Shutter angle is a term that comes from shooting a film or a movie, where instead of a shutter opening and closing like it does for still cameras, a disc will spin in front of the film as it moves past the lens, rotating 1 full revolution per a frame of film. That disc will have an opening in which light is allowed through to expose the film. A disc is of course 360 degrees. An opening in that disc is what is expressed as the shutter angle. So 180 degree shutter is a disc that has 180 degree opening, or exactly 1/2 the disc. You can choose much smaller angle or a large one, but of course the shutter angle can't be anything bigger than 360 degrees or open all the time. That's an important point. Remember that converting shutter angle to shutter speed requires that you know the frame rate or frames per second as well. A 180 degree shutter at 30 frames means the shutter is open for 1/60th of a second. 180 over 60 equals 1/2 or half. At 30 frames per second, the longest an exposure can possibly be is 1/3 of a second, and half of that is 1/60th. Since the shutter can't be open for longer than that frame being recorded, your exposure duration is limited. Just like the shutter angle can't be more than 360 degrees at any frame rate, the shutter speed can't be more than 1 over the frame rate if you are shooting at 30p, that's 1/30th of a second. Shoot 60p and that drops to 1/60th and so on. So again, remember that limitation. Now let's talk about electrical power. Unlike the light from the sun, which is constant, electric light requires a power source, and an AC power system isn't constant. Just like the name implies, AC stands for alternating current. It delivers power in a very fast fluctuation that we measure as frequency. In North America, they use a 60 cycle per second frequency called 60 Hz, and most of the rest of the world uses a 50 cycle or 50 Hz system. The power fluctuation follows a sine wave with 2 peaks per cycle. So a 60 Hz system has 120 peaks per second. A 50 Hz per second has 100 peaks per second. This cycle delivery source means that a light it is powering actually gets turned on all the way up to its maximum brightness, then drops towards 0, briefly passing 0 before moving back to full power again, that's 100 or 120 times per second, introducing a flicker. This flicker is so fast for the human eye to detect, so we don't normally see it, but it's happening when shooting a video. Under this kind of light, it is critical that the shutter speed or shutter duration lines up with a sine wave perfectly. when the exposure starts and ends at the same part of the sine wave, then the amount of light exposing the film or sensor is always the same. However, if the exposure pattern gets out of sync with the sine wave, then the exposure isn't constant and we record darker and brighter frames, which is seen as a flicker. Let's go back to the statement that only one of the two factors, frame rate or shutter speed or angle, have to be right to avoid flicker. Let's begin with frame rate. When you are shooting at 30 frames per second under 60 Hz lightning, you can use absolutely any shutter speed or angle you want. Why? Because the frequency and frame rate are evenly divisible, meaning each frame starts recording at the same point on the sine wave, which means that no matter the duration of the exposure, it will always end at the same point of the sine wave. The shutter speed can be anything you want that fits within the time limitation we discussed earlier, and you have an even exposure. The math is actually really simple if you go the other way and just divide your power frequency by the whole number, allowing you to find all the easy frame rates. Remember, 60 Hz is 120 pics per second, which is ultimately what we are concerned with. So 120 divided by 1 is of course 120, meaning you can shoot easily at 120 frames per second. 120 divided by 2 is 60 frames per second, by 3 is 40, 4 is 30, 5 is 24, and so on. If you are shooting at a 50 Hz environment, then you can shoot flicker-free at any shutter speed or angle at 100 frames per second, 50 frames per second, and 25 frames per second. Note that the standard broadcast format in NTSC for North America is 29.97 frames per second and not exactly 30 frames per second. When you see a camera that says shoot 30 frames per second, it's actually 29.97 frames per second, and 60 frames is actually 59.94. So technically, these don't line up perfectly with the 60 Hz power, but in reality, they are so close that there is no perceptible flicker. Moving on, now that you know what frame rates are easy to shoot at, what happens when you want to shoot at a frame rate that is not evenly divisible, like 105 or 75 frames per second? Or more likely, you need to shoot at a common frame rate for you, but you are shooting outside of your home region. For example, shooting 30 frames per second in a 50 Hz region. Well, remember, to avoid the flicker, you only have to get one of the two factors aligned. And since frame rate is not in alignment, that means just the shutter speed or angle must be perfect. So what does this actually mean? Let's use shooting 30 frames at a 50 Hz lightning as our example. When you divide 50 Hz or 100 pics by 30 frames, you end up with 3 1/3 pics per frames. So that means each frame does not start its exposure on the same part of the wave. This uneven starting point means that for most exposure duration or shutter speeds, the amount of light hitting the sensor during each exposure would be different every time, resulting in an uneven exposure across frames, which is where the flicker comes from. But it turns out that if the exposure starts and ends at the same part of the wave, the same point along the curve, then the total light reaching the sensor will in fact be the same in every frame. Each frame can be a different starting point as long as it ends on the same position that it starts on. So, to get consistent exposures across every frame, the exposure itself either has to start at the same point of the wave for every frame of video and then end anywhere, or the exposure has to start and end at the same position of the wave, but that can be anywhere along the wave and different from every frame. So how can we figure out what that shutter speed should be? Well, that's just math, and there are plenty of tools out there to make it easy. You can use the website red.com/flicker-free-video and the app Flicker Free on iOS. You just punch in your frame rate and choose 50 Hz or 60 Hz, and it gives you the shutter angle or shutter speed to safely shoot at. I came across Photo Joseph's formula, 1 over the frame rate times the shutter angle over 360 equals n, an integer or whole number over the frequency 120 or 100 degrees. So continuing with 30 frames at 60 Hz region example, That means the available shutter angles are 1 over 30 times A over 360 equals 1 over 100. So A equals 108 degrees. The next integer is 2. So that math becomes 216 degrees. And with 3 is 324 and the next would be 432. However, we cannot have more than a 360 degree shutter. So 108, 216 and 324 degree shutter are our options. Great! Now how about converting these shutter angles to shutter speeds? When it comes to avoiding flicker, it's actually a lot easier to work with shutter speed than with shutter angle because no matter the frame rate, the math always reduces back to the same few shutter speeds. The hard math is to multiply the shutter angle as a fraction, like 108 over 360 by 1 over the frame rate, like 1 over 30, and you will get a shutter speed. But no matter the frame rate, the answer will always be one of the same few numbers. For 60 Hz power sources, these numbers are 1/120th of a second, 1/60th, 1/40th, 1/30th, and 1/24th. For 50 Hz sources, these numbers are 1/100th, 1/50th, 133 and third, 1/25th, and 1/20th. How did we arrive there? Well, pretty easy. 120 divided by 1 is 120. 120 divided by 2 is 60. By 3 is 40. By 4 is 30. And by 5 is 24. 100 divided by 1 is 100. By 2 is 50. By 3 is 33 and third. By 4 is 25. Nice and easy. The problem is that most cameras don't accommodate all the shutter speeds. Most cameras give a 1/125th of a second and not 1/120th. You'll probably find 1/100th, 1/60th, 1/50th, 1/40th, 1/30th, and not 1/33 and third. And finally, you will have to choose 1/25th instead of 1/24th. If your camera is capable of shooting in shutter angles like the J5 and the J5S, you can be more accurate by selecting shutter angle instead of shutter speed. But for most users, relying on shutter speed is perfectly fine. There's one more point I would like to make, and that's why you can't shoot really high frame rate under AC powered light. Remember in the beginning, I said that you can choose much smaller angle or a large one. But of course, the shutter angle can't be anything bigger than 360 degrees or open all the time. That's an important point. Or that the shutter speed can't possibly be more than 1 over the frame rate at 30 frames per second, and the exposure can't be longer than 1/3 of a second, or it overlap into the next frame. Under 60 Hz lighting with 120 pics per second, now we understand that we can't have less than a full way of exposing a frame without introducing flicker. The minimum exposure duration is going to be 1 full wave. Anything less would mean we wouldn't be starting and ending the exposure on the same position of the wave, which means we can shoot anything faster than 1/120th of a second, which means we can't have more than 120 frames per second. The good news is there are ways around this if you have control of your lighting. You could use DC power instead of AC. That's battery instead of from the wall. DC is direct current instead of alternating current, and the whole flicker issue just goes away. LED lighting shouldn't flicker. It can if it's dim, but full power LED should not flicker, and really good LED should never flicker.